Welcome to Tennessee's at-home learning series for math. This lesson is for all our 7th graders out there, though all students are welcome to tune in. This lesson is the 11th in our series. My name is Kayla Anderson, and I'm an 8th grade math teacher at Rocky Fork Middle School in the Rutherford County School District. Thank you so much for welcoming me into your home. Welcome to my virtual classroom. If you haven't seen our previous lessons, you can find them at www.tn.gov/education. If you don't have the student packet, you can find that at www.tn.gov/education. If you haven't seen the previous lessons, you're welcome to tune in, but it may be more fun if you first go back and watch those other lessons, since we'll be talking about things we've learned previously. Today we'll be discussing finding unit rates with ratios of fractions and using them to solve multi-step problems. Before we get started, to participate fully in today's lesson, you will need paper, pencil, a surface to write on, and you may want to have that student packet from the website that I mentioned before. Okay, let's begin. Let's start by looking at a situation in which we can use rates to solve a problem. So here's our first problem. Allison and her pen pal Yuki planted bean seeds at the same time. Allison and Yuki video chat about their seedlings. Allison says her plant has grown 2.5 inches in 5 days. Yuki says her plant has grown 5.5 centimeters in 4 days. Okay, Allison's plant grew 2.5 inches in 5 days. I wonder how many inches it grew per day. We can create a ratio that will help us think about this situation. Let's start with our ratio. So 2.5 inches in 5 days. Okay. Let's use this ratio and let's now create a unit rate. Remember that a unit rate is a rate with a denominator of 1. If we want this rate to become a unit rate with a denominator of 1, notice that the denominator, which is the bottom number of this fraction, is a 5. If we divide by 5, then our denominator is going to become 1 day. So 5 days divided by 5 gives us a denominator of 1 day. To make sure that we're creating an equivalent ratio, we have to also divide the numerator by 5. Once we've done that, we get 1/2 inches. So we have our unit rate 1/2 inches, or 1/2 an inch, every 1 day. What does this mean in the context of the problem? Right, it means that Allison's plant grew 1/2 an inch every day. Okay, that's going to be important. We'll come back to that. Okay, so let's think through some more of this problem. Yuki says that her plant has grown 5.5 centimeters in 4 days. That highlighter doesn't work. Let's try a different one. 5.5 centimeters in 4 days. Okay, there we go. How many centimeters did her plant grow per day? Well, just like we did for Allison, let's create a rate. So if we first set up our ratio here, 5.5 centimeters in 4 days. Okay. So now that we have this rate, how do we create a unit rate? Remember, a unit rate is a rate with a denominator of 1. That is correct. We want to divide both the numerator and the denominator by 4. Dividing by 4 means that we're going to have a denominator of 1 day. Dividing our 5.5 centimeters in the numerator by 4 leaves us with 1 375 thousandths centimeters. So what does this mean in the context of the problem? That's right. This means that Yuki's plant grew 1 375 centimeters each day. What if we wanted to compare which of these plants grew more? Do you think it's Allison's or Yuki's? Make a guess, write it down, and then we'll do the math. Well, how can we compare inches and centimeters? Allison's plant is being measured in inches, whereas Yuki's is being measured in centimeters. How can we compare those? You are correct. We need them to be the same unit. So we have to convert one of them into the other one. Do you know how many centimeters are in an inch? I hope you said that 1 inch is equal to 2 54 centimeters. So if Allison's plant grew 1 inch every 2 days, so 1/2 an inch every day, 1/2 an inch every day, or 1 inch every 2 days, then that 1 inch is equal to 2 54 centimeters. So 1 inch is 2 54 centimeters. And we're needing to divide by 2 because Allison's plant only grew 1/2 an inch. So you can think about it a couple ways. 1/2 an inch every day. So here we're needing 2 in the denominator, or 1 inch is 2 54 centimeters. I should label that. But Allison's plant only grew 1/2 an inch, so we have to divide by 2. Okay, so once we've done that, 1/2 of an inch is equal to 1 27/100 centimeters. This means that Allison's plant grew 1 27/100 centimeters per day. So whose is growing faster? Yuki or Allison? That's right. Yuki's plant is growing faster since it grew 1 375 thousandths centimeters each day, and that is greater than the 1 2700 centimeters that Allison's plant grew. How many of you guessed that? Awesome job. Now that we've reminded ourselves of how to use ratios and rates to solve problems, let's do some more examples. Let's talk about finding a unit rate. What's a unit rate? Remember that a unit rate is a rate with a denominator of 1. So here's another problem for us to look at. Sergio is training for a triathlon. His target speed on his bicycle is 25 miles per hour. He recorded a distance of 7 miles at 15 minutes. Did he achieve his target speed for the first 7 miles of his ride? Well, what do we know? We know that Sergio wants to ride his bike at a rate of 25 miles per hour. We know that Sergio goes 7 miles in 15 minutes. So what are we trying to find out? What's the problem asking us to do? The problem is asking if Sergio is going 25 miles per hour in the first 15 minutes of his trip. How can we figure that out? We see that we are given how far Sergio rides in 15 minutes, but the problem asks about miles per hour. Maybe we should convert 15 minutes to hours. So what's the relationship between 15 minutes and 1 hour? What's the relationship between those? Well, since there are 60 minutes in an hour and 15 minutes out of 60 minutes, so 15 minutes have passed. There are 60 minutes in 1 hour. So 15 out of 60, or 15 minutes out of 60 minutes is 1/4. So 15 minutes is 1/4 of an hour. How can we use a unit rate to describe Sergio's cycling speed? Well, first, let's write a ratio. Remember that a ratio is a comparison of two values by division. So from the problem here, our ratio is going to be 7 miles in 15 minutes. Can you draw a diagram to show how the distance Sergio bikes is related to the time he bikes? Let's draw a diagram. Since we're given 1/4 of the hour, we can think about what this would look like for the entire hour. How many 1/4 are in 1? Yes, there are 4. So we can label each. So there are 4 1/4. If this whole thing is an hour, there are 4 1/4 of an hour in our hour. And we can label each 1/4 of an hour with 7 miles because he went 7 miles in 15 minutes. Remember that 15 minutes is 1/4 of an hour. So we have 4 of those 1/4, and each of those in that 1/4 of an hour, he can bike 7 miles. Since we have 4 of those sections, 7 miles times the 4 sections equals 28. So we know that Sergio's speed was 28 miles per hour. If he can go 7 miles in every one of those 1/4 of an hour, he can go 28 miles in the entire hour. So we know that his speed was 28 miles per hour. Can you make a table to find a unit rate? Let's make a table. We are given distance in miles and time in minutes. We have converted the minutes to hours already, so our table would look like this. 7 miles in 1/4 of an hour, because remember that the 15 minutes was 1/4 of an hour. So 7 miles in 1/4 of an hour. We know that 1/4 hour times 4 is going to give us a whole number, or excuse me, a whole hour. So since we multiplied our time by 4, we also have to multiply our distance by 4. So I'm going to multiply by 4, because multiplying by 4 is going to give us an entire 1 hour. And since we multiply by 4 here, we have to also multiply by 4 here, giving us 28. What does this mean? Right, his speed was 28 miles per hour, and Sergio achieved his goal. We just did a problem where we had to convert minutes to hours. Let's look at a problem where we are given time as a fraction of an hour. Let's think about this situation. Excuse me. Bronwyn mows the lawn every other weekend. She can mow 12,000 square feet in 2/3 of an hour. The lawn is 36,000 square feet. How long does it take her to mow the entire lawn? Well, let's create a ratio that tells us how many square feet per hour Bronwyn mows. What would that ratio look like? Since she mows 12,000 square feet per hour, or excuse me, not per hour, she mows 12,000 square feet every 2/3 of an hour. So the ratio would look like this. We need a unit rate. Remember that a unit rate is a ratio that has a denominator of 1, and the denominator is the number on the bottom of the fraction. What can we multiply 2/3 by to make it be 1? So we want 1 hour here so that it's a unit rate. What can we multiply by? Did you say 3/2? That's right. How can we keep our ratio, which remember that a ratio is a fraction, how can we keep that equivalent? That's right, we have to also multiply the numerator by 3/2. Good job. So we're going to multiply by 3/2, and to keep that equivalent, multiply by 3/2. We can think about this as 12,000 times 3 and then divided by 2. So 12,000 times 3 is 36,000, divided by 2 is 18,000. And then 2/3 times 3/2 is 1. So it gives us 18,000 square feet every 1 hour. Now we have a unit ratio. Remember that a unit ratio is a ratio whose denominator is 1. What does this mean in our problem? It means that we now have the time in 1 whole hour. So what's our answer? Well, this means that Bronwyn can mow 18,000 square feet in 1 hour. Remember that the lawn is 36,000 square feet. So how long will it take her to mow the entire lawn? Well, this 36,000 divided by 2 is 18,000. So it's going to take her 2 hours. We could also think about this in a table. So let's create a table for this problem. If we've got our area in square feet, we're also discussing the time, and that's in hours. Okay. So we know that she can mow 12,000 square feet in 2/3 of an hour. So notice that when we used a fraction, we had a numerator of 12,000 and a denominator of 2/3. So here we have that same thing in the table, 12,000 and 2/3. Okay, so then we are multiplying by 3/2, because remember that we wanted that to be 1 whole. So 2/3 times 3/2 is 6/6, which is the same as 1 whole. Well, if we're going to multiply this one by 3/2, or 3/2, then we have to multiply by 3/2 here as well. And 12,000 times 3/2 is 18,000. So here you can see what we have, what we represented with our ratio is here in the table. 18,000 square feet in an hour is here as well. Okay, and so then we know that we need, let's add on to our table a little bit. We know that we needed this to be 36,000 square feet. That's how many square feet the lawn is. Well, 18,000 times 2 is the 36,000 square feet that the lawn is. So 1 times 2 is 2. So this is 2 different ways that you can approach this problem. Both ways are correct. Which way do you like better? Sometimes I like to use a ratio that looks like a fraction, and other times I like to use a table. You're doing a great job, folks. Let's look at another one. Now let's look at a problem where the numerator and the denominator in the ratio are both fractions. Let's look at a map. Omar knows that his friend Chris lives 3/5 mile away. How far is the school from Omar's house? What do you notice about the map? What information are we given? Well, we can see from the map that the distance from Omar's house to Chris's house is 3/4 of an inch. The distance from Omar's house to school is 2 inches. Let's think about the scale of the map. We know that Omar's house is 3/5 mile from Chris's house. It tells us that here. So Omar's house is 3/5 of a mile from Chris's house. Well, we can see on the map that that distance is marked as 3/4 of an inch. So 3/4 of an inch on the map actually represents 3/5 miles. So how can we determine the actual length of the 2-inch distance from Omar's house to school? Well, using what we know, we can set up a ratio. We know that 3/5 of a mile is 3/4 of an inch on the map. How can we write this as a unit rate? How can we change this 3/4 in our denominator to 1? That's right, we can multiply by 4/3, because 3/4 times 4/3 is 1. Well, if we multiply by 4/3 in the denominator, we have to multiply by 4/3 in the numerator as well. Once we've done our multiplication, we get 4/5 over 1. What does this mean? It means that 1 inch on the map represents 4/5 actual miles. So how does this information help us determine the distance from Omar's house to the school? Well, now we know the scale. We know that 1 inch is 4/5 of a mile. So how can we determine the actual distance if the map says that it's 2 inches? Well, if 1 inch is 4/5 of a mile, then 2 inches must be 4/5 of a mile times 2, which is 8/5 miles. It's equivalent to is represented by 2 inches. So that 8/5 miles is the same as 1 3/5 miles. So it's 1 3/5 miles from Omar's house to the school. Good job. We've looked at using ratios to represent problems. We've looked at creating unit rates to help us think about the situations in a different way. I think you're ready to try some on your own. Remember Sergio? Let's think about that problem again. Sergio increases his target speed to 30 miles per hour. How many more miles does Sergio need to ride in 1/4 of an hour to achieve his target goal? Well, I'm going to set up a table. You can do this whichever way you choose. So we're talking about miles, and we're talking about hours. Well, we know that he can go 30 miles in 1 hour. But we want to know how many more miles he needs to ride in 1/4 of an hour to achieve his target goal. Well, why are we dividing by 4? 1 divided by 4 is 1/4. 1 divided by 4 is 1/4. So if we divide 1 by 4 to get 1/4, we can divide 30 by 4 to get the missing value. Well, 30 divided by 4 is 7.5. What does this mean? Well, it means that Sergio must ride 7.5 miles in 1/4 of an hour to achieve his target speed. So he needs to ride an additional 1/2 a mile per quarter hour. Because if you think back, let me find the original problem. If you think back to our first problem about Sergio, he was going 7 miles every quarter of an hour. We just figured out that he needs to go 7.5 miles in 1/4 of an hour. So he needs to go an additional 1/2 a mile in that quarter hour to reach his new target speed. Great job. Let's think about the earlier problem with Bronwyn. Every other weekend, Bronwyn's brother Daniel mows the lawn. He can mow 15,000 square feet in 3/4 of an hour. Who mows the lawn in less time? Well, recall that Bronwyn mows the 36,000 square feet in 2 hours. How long is it going to take Daniel to mow that 36,000 square feet? Well, let's set up a ratio. Daniel can mow 15,000 square feet in 3/4 of an hour. Does your ratio look like this? Great. How can we create a unit ratio? Well, if we multiply 3/4 by 4/3, we're going to get a denominator of 1. We also have to multiply our numerator by 4/3. Well, 15,000 times 4/3 can be thought of as 15,000 times 4, which is 60,000, and then divided by 3, which is 20,000. So what does this mean? Well, it means that Daniel can mow 20,000 square feet in 1 hour. So who mows the fastest? Well, remember that Bronwyn mows 18,000 square feet in 1 hour, and Daniel mows 20,000 square feet in 1 hour. So Daniel mows faster. Well done. Let's try another one. This time you try this one on your own, and then we'll do it together. I know you can do this. Oops. So recall our map problem. Sonoma bikes 5 miles to Paige's house. On a map, they measure that distance as 5/6 centimeters. The same map shows that the mall is 3.5 centimeters from Paige's house. What is the actual distance between Paige's house and the mall? Well, how can we write a ratio? 5/6 centimeters represents 5 miles. How can we rewrite this so that we know how many centimeters per mile? Well, we need the denominator to be 1. The way to do that is to divide by 5. And if we divide the denominator by 5, we have to also divide the numerator by 5. 1 mile, not 1 miles. Sorry about that. Well, 5/6 divided by 5 is 1/6. So what does this mean? Well, it means that each 1/6 centimeter on the map represents 1 mile. So if it's 3.5 centimeters from the mall to Paige's house, how far is it actually? Well, we can take that 3.5 centimeters and divide by the 1/6 that represents every mile, which is going to give us 21. What does this mean? It means that it's actually 21 miles from the mall to Paige's house. Okay, great work, 7th grade. Today we reviewed how to find unit rates with ratios of fractions and use them to solve multi-step problems. You sure did a great job. After the video, you will have some problems to practice on your own. I will show you the independent practice problems now, or you can find them in the student practice for this lesson posted on the website www.tn.gov/education. There you go, guys. Good luck on this and do your best. Well, folks, I really enjoyed finding unit rates with ratios of fractions and using them to solve multi-step problems with you today. Thank you so much for inviting me into your home. I can't wait to see you for our next Tennessee's at Home Learning Series lesson. Bye!